Bit of a shorter video today, and I wanted to talk about validating your designs to make sure it works the first time and to make sure the amount of debugging you go on, so on and so forth. Though we all wish this is reality and we still face these problems, but it can be achieved. Purchase pre-made boards, use dev board layouts, it works, purchase evaluation boards to test your idea and try out, follow application notes. So by using a dev board layout, we know the dev board works, we can apply that in our own designs, especially for microcontroller designs, newer chips and such. It can still go wrong. I hope you do realize that it's not a surefire way, but I'll get to why this is important. This will still decrease the amount of time it will take as using something that does work, that you can see it works and you can have something to reference to. You can severely decrease the amount of time for your debugging process, and this is something that I have done. So I've made a board, I've used a reference schematic, and I've still connected something wrongly or I've misread something, and I can refer to the data sheets and whatever to correct that. Purchase evaluation boards to test your idea and try out. So evaluation boards, they can get pretty expensive, I do realize that, but if it's a critical project and you really want to make it success, I would seriously flirt with the idea of buying one. So let's take, for example, this evaluation board here. This is the DRV8835. This was the evaluation board I used for this recent motor control project. This is what I've based my designs off, and I know this works because I've literally quite tested this board out with different motors and whatever the motor I want to use, and I was quite happy with it. It did everything that ticked off for me, so I've implemented the exact same thing in my design, and I've tested it on this board, so it should work on my board. Though, like I said, things can go wrong, but we have this reference to try out. Follow application notes. So with this, again, application notes, I just wanted to throw this out because it seems like a bit of a no-brainer. But so when I first started out, I did not know application notes exist, and I was only thinking about the datasheet. Had I not got the relevant information I need from a datasheet, how to integrate this part, how to use this part, I would give up, choose something else, which is very bad practice on my part and just seems a bit lazy. Though I discovered the holy grail of application notes from manufacturers, and everything seemed a whole lot more easier. It gave me integration manuals, it gave me tips on RF design, it gave me everything. A lot of my learning was quite literally from these applications, just steadily increasing myself as well from other books and stuff. But these application notes give you such a wide variety of design tips that you would not get formally, and it's kind of just something you pick up along the way. So I highly recommend you do this, especially if you're just starting out. Prototype certain sections if you can. Build upon certain parts on perf board / breadboard and stimulate designs if you can. So what I mean by this is, you've got a massive project. I know it's going to work because if for you guys, it's definitely going to work first time, like compared to what I do and everything. But I usually like to separate little things into smaller parts. So something I've really tried to incorporate more recently is breaking up little parts before I build the whole entire thing. So maybe if I've got a project and I've got several hundred new different parts, theoretically I would love to just break them down, build smaller PCBs, make small changes and try and get the certain parts to work. So maybe I'm using a new audio circuit or some sort, I want to see if that works. Or maybe I'm using a new power supply source, I want to see if that works perfectly. Maybe I've got some fancy analog thing, I want to see if that works perfectly. And this is how I go by it, and this is what you de-risk it. And hopefully when you're just joining that all together, like some pieces of blocks, and you're playing and it's like playing Tetris, and it all clears away and you get a perfectly good working circuit. The simulation part of this is quite essentially the same thing. Simulate your designs if you can. So the simulation packages nowadays are quite scary, they're really accurate, and especially for the analog stuff, they're really decent. So especially if you had unfamiliar with something, it might be the extra time and everything, but I would highly recommend you do that before incorporating to your design, because it'd be much cheaper than getting the whole board made and wondering what to do. So anything you can simulate, just chuck it in there, chuck a file in there to say you've done it, this is how it's going to work, and you've got that reference again, and hopefully it should work in the field. So here is a application note I was speaking of, and this was an application note that I've took for a C2H4, which is ethylene. And this is something that I want to say here, that even though this is took from an application note from the manufacturer, I'm not too sure how the circuit works. So I know how it works from a base level, as so do you, and the manufacturer has showed me the application and said this is how the circuit works, this is what's meant to do and such. So here, so I've took this, and I should put a pull down here, I think, just to ensure. And I've took this, and I wanted to be sure what is going on here? What am I actually doing? This is just a base circuit actually. So if you actually read further into this note, this is just the base. So this is just how to get something quick up and running, but you can slightly tweak this to your own design. So it says here this is to switch it off, but of course there's no FET here, so you have to add in the FET yourself or some GPIO signal if you're not using the sensor. And these two would short effectively, so these two would short. And I would build this circuit by itself first, see if it works, see how it works, understand it before placing the order, before going through the whole design process. Like bam, this is ready. This is what I mean by building certain parts up, and then you can reuse this part for the future, and you only need to slightly tweak some values if ever. Design reuse, this is the good stuff. It's not lazy if you know it works. So this is what I've been talking about for the last 5 minutes or so about designs. Once you know it works, keep at it, keep it somewhere safe, put in a block or something, and you can just reuse it ever again. This increases productivity, efficiency, and the product works before. What I mean by this is that it works before, you've used it in the design, why not reuse it again? Why go through the whole entire raft of component creation, testing, reading, whatever, if you got a part that might as well works? It's a trade-off between how much you want to do, and really not everyone enjoys the whole component creation process and whatever. I certainly don't, and not everyone wants to go through the whole debugging phase also, or bringing the board up. You want to get out the door as soon as you possibly can, and to a good working standard. So let's take this part again. If I knew this works, if I knew everything this worked, I could retake that design, implement it in my new design, and I say, oh, okay, I know this design works because I've used it before, so I have no need to pick a new ethylene sensor. Or if it meets the requirements, do I need higher resolution, and maybe I need to pick a new one, so on and so forth. But this is what I meant from the motor driver project, that I picked that buck boost converter because I know it works, and I didn't want to go through that. So that's one portion of a section that I do not need to particularly look at that much because I know it works. So I hope you see where I'm getting at here, and that even though I should have really picked a buck converter at the time because I'm driving it from a USB-C power port, like 5 volts to step it down and whatever, but I know that section works, and that's all there is to it. So it puts one thing out of the way. So that's all I wanted to cover in this video. I hope you do have learned something, especially for those that are new. I imagine the more experienced and more talented viewers out there like yourselves would probably do all this already, but this is something I've just recently, not recently, well, started really trying to implement and everything. I really want to try and make a push for it, so I thought it'd be nice to share with everyone. So I hope you learned something.